Hello everyone, this is Pedram. I am a graduate student in the field of chemical engineering, process design, and currently I'm studying computer science and engineering at McMaster University. In this video, I'm going to show you how to link Aspen Plus and Matlab as user model with the help of Excel, while Excel only operates as a data transmitter. There are some simulation software in the field of, for example, chemical engineering, such as COMSOL and ANSYS Fluent, which makes us able to simulate a single unit. And there are also other softwares such as DWC, Aspen Plus, Aspen HiveSys, and Coco, which makes us able to simulate the whole process. Um, some of them are free license, for example, Coco, and it can also directly exchange data dynamically with Matlab. Uh, but Aspen Plus, if you don't have a problem with license, for example, if you're working for a company or studying at a university, which they have the license, I strongly suggest you to use Aspen Plus since they have a wide range of components and fluid package. The data bank inside Aspen is much more stronger than other simulation software, as much as I know. The question is why we need to put our own developed model inside even a sophisticated simulation software such as Aspen Plus. This is a sample. This is the simulation of a whole process which we can do it inside Aspen Plus. I already know that Aspen is able to simulate many equipment such as these heat exchangers, flash drums, compressors, and pumps, distillation towers easily. But as much as I know, uh, for example, these reactors are a little bit complex, and built-in models available inside Aspen Plus cannot accurately model these reactors. In this reactor, there is a continuous circulation of catalyst inside the catalytic bed axially, but the gas flows and enters the catalytic bed radially. So someone may want to solve and model this particular reactor by his own developed equations and solving differential equations in one dimension, two dimension, and so on. So that is why we need to develop some models in another software and put it into the middle of the whole process. When we have an integrated simulation, we can investigate, when we develop the whole simulation, we can investigate the effects of different parameters on the final product. For example, in this case, it is hydrogen. When we have a comprehensive simulation, then we can carry out more reliable optimization based on market demands, which is constantly changing. There are many models out there, for example, for the catalytic reactors, which uh, it is used for different purposes, such as wastewater treatment, and as much as I know that Aspen built-in models cannot model this particular reactor accurately. Solar cells are another example of a model which built-in models available inside Aspen cannot model. This is another example of a reactor, a spherical reactor. As you may know, some engineers mm, design a reactor spherically to decline the pressure drop within the catalytic bed. And in this particular reactor, there's also a membrane which allows only hydrogen to permeate through the membrane. There are also some complex models out there in the field of chemical engineering that someone may prefer to use artificial neural networks to model the output. In this example, the molar flow of each component, temperature and pressure, can be the output of our neural network. And So we need to simulate, we need to develop our own model, and then we can put it into the simulation environment of Aspen Plus. Fortunately, Aspen engineers have provided us with a feature which is called user model that makes this process easy. If you take a look inside the Aspen Plus simulation environment, on this section, model palette, user models, there are different blocks which makes us able to put our own developed model in another software. And the idea is quite simple. You can find about these issues which we are talking about in these references. There are different ways also, such as using Aspen Custom Modeler or using Fortran. But in this video, we are only going to focus on linking Excel and Aspen as user model. The idea is simple. Aspen must be able to automatically and dynamically send the input data to Excel and receive the data after the calculation inside the Excel. At this stage, someone may develop the simulation inside Excel by using solvers which are available inside Excel. But any software which is also able to dynamically exchange data with Excel can be used as our user model, such as Python, Matlab, TensorFlow, and so on. So maybe I want to develop, I want to program my model by using differential equations inside Python, Matlab, and then send the output to Excel. In this case, Excel will operate as a data transmitter. But in this video, again, we are going to only focus using Matlab. Here I have provided a simple example to make sure that these three software are able to dynamically exchange data. The molar flow of inlet stream is here for two different components, water and ethanol, with a specified pressure and temperature. First stream and second stream are our outlet streams. 60% of total inlet flow is equal to first stream molar flow, and the remaining is for second stream. The pressure of first stream is 2 bar and the temperature is 31 degrees Celsius. But like I said, this is just a simple example. Someone may predict the outlet temperature by using heat balance differential equations, or even someone which is simulating a reactor, a catalytic reactor, may use ergon pressure drop to predict the outlet pressure. But this is just some numbers to make sure that these software are exchanging data correctly. And the mole fraction of both outlet streams are equal to that of inlet stream. So there isn't any reaction or separation inside our user model. To solve this example, I'm going to break it into a few simple examples. In this section, I'm going to only focus on linking Aspen and Matlab. So the idea, like I said, is quite simple. Aspen must be able to send input data to Excel, and Excel will calculate the output, and Aspen must be able to automatically receive the output. Okay, I have already opened our simulation inside Aspen. I have added two components, water and ethanol, like I said. And in this section, I've chosen pen parameter as our equation of the state. You can choose whatever you want, that doesn't matter. And if you take a look to our example, okay, the name of our inlet stream is IS, so I'm going to change the name of this stream to IS. The temperature is 25, the pressure is 1 bar, and the total flow is 100, the summation of 70 and 30 of water and ethanol. and the mole fraction is also these numbers. Okay, so now I'm going to use user2 block. You can find about which one is necessary for this simulation for linking to Excel in those references which I have already mentioned, but make sure that you are using user2. So I'm going to connect this string to our user block and first string. Okay, and the second string, this is fs, and this string is also ss. I can change the name to whatever I want and make it more beautiful. Okay, let's see what we've got under this user2 block. In this section file, Excel file name, I have to write down the Excel file address to dynamically exchange data between between Aspen and Excel. We have to write down some code in VBA section of Excel, but fortunately Excel Aspen engineers have provided. If you want to develop your model, you can again check out the references to find the template which Aspen engineers have provided. You can take your time, pause the video, and you can find it here. Okay, so I'm going to find our template. Engine user. Okay, there is two Excel file here. One of them is 95, which is as much as I know, I think it's for Excel released in 1995. But for more updated versions of Excel or Office, you have to use this one. Okay, I'm going to copy this one and paste it right here. Okay, I can change the name to whatever I want. That doesn't matter. I'm going to say it's, for example, user. Okay, so I want to copy this address. Get back here. Paste. Okay, it is the same folder. I'm going to open this Excel template. Okay, there is a section which is called user arrays. Any parameters which I want to be able to manipulate in here in Aspen Plus simulation, I can write it down here and send the data as a single matrix to Excel. For example, I want to be able to send this 60% and manipulate it from exactly here. So I'm going to say 6, and it is the flow fraction of first string. Okay, I also want to be able to send these pressures for first string and second string. So I'm going to say pressure of fs and pressure of ss. Okay, so it was 2. Okay, it was 2, and it is 4.5. 4.5. Okay. This is a checkbox which says if the output is 0, just bypass the this specific block. If you want, in this case, you will have only warnings, not errors. So whatever you want, you can do with it. In this section, I'm going to say the Aspen flash the streams by temperature and pressure. In my model, in my example, I'm going to calculate only temperature and pressure and molar flow of each component. And these are the minimum requirement data which any equation of a set takes to calculate other properties, like I said, molecular weight, density, and so on. So I'm going to say the same about second string. So here it is, and I'm going to open the template which we copy here, which we pasted here. Apparently my Excel is linked to Matlab, so it is taking some time to open the Excel file, but I'm going to remove it. That doesn't matter. Okay, here the Matlab is linked, so I'm going to pause the video and disconnect this one because we are going to talk about this specific issue in the next section. At this stage, I'm going to enable the content. Make sure that you're clicking that one. So sorry, I'm going to pause the video and disconnect the Matlab. Okay, Matlab now is disconnected. Here I don't have any icon about Matlab. So let's take a look inside on what we've got in this template. Apparently, the template, the example which they have provided for us had two streams as input streams. The output also had two streams, and this is the real params. The data which we have defined here will be sent in this section. And under this section, developable Visual Basic, we can write down our program. This is, like I said, you can find about these codes inside the references, which I have already mentioned. And the thing which we will going to use is only this function, public function. If you are writing VBA code to solve your model, call it from here. So after, if we want to link the Matlab to calculate, link Excel and Matlab to calculate the output, we are going to write down the code here. Before that, I'm just going to add some references. Okay, to link Matlab, to link Aspen and Excel, you need to add some references. I don't remember which one of the what is exactly standing for dynamically exchanging data between Aspen and Excel. Just add all of them, but this one, a spreadsheet link, is for only linking Matlab and Excel. We will talk about that in section 2. Add all of the remaining ones actually. Okay, so get back here. Aspen calculator block, Aspen custom modeler, UI, and property Excel. Okay, so everything is fine. I saved this VBA, and to make sure that everything is okay, I want to check it again. Okay. If you didn't have access to this code, you can find it here, modules, and this section is the code. Okay, I'm going to close this one. Getting back to here. So at this stage, I want to make sure that only Aspen is able to send data, nothing more. I just want to send data from Aspen to Excel. Okay, I'm going to get back here and press the run button to see what would happen. I didn't calculate the output, so I assume I must have some errors or warnings here. Okay, here it is. It is saying that total flow is 0. If you check the mass balance, I can see that nothing is as the output. I can sit here because I didn't specify the calculation in Excel. Okay, everything is 0 and empty. Or okay, let's see what happened for Excel file. This is the input. Okay, the name has changed. IS was my inlet stream, so I can remove this column. Okay, the numbers are exactly equal to numbers which is for my inlet stream. Okay, um, don't change this sheet. This is Aspen Output pet. That is exactly the name of my user to block. Don't change this one. Okay, let's see what is the Aspen output. Like I said, I didn't calculate the output. I didn't program anything here to calculate the output of first stream and second stream. And Aspen real params is exactly showing the matrix which I have defined here. 60% 2 and 4.5 is exactly they are exactly the numbers here. So as Aspen is actually sending data to Excel accurately. Now I want to send back this data to Aspen. Okay, send back the output. Okay, to calculate the output, I must calculate these parameters, these variables, or okay. So what is the total flow of first stream? It is equal to this number, 60% of total inlet flow, okay? And the remaining is for the other stream, okay? You can check your code here. Okay, if I say that the summation of these two cells, it must be exactly equal to this cell. It is. So we are doing it correctly. So what is the molar flow of water? Like I said, the mole fraction of output streams is exactly equal to inlet streams. So what is the mole fraction of water and ethanol? Mole fraction. It is equal to this cell on the total flow, and the other one is also the cell total flow. Okay, and I'm going to say that this molar flow of water for first stream inside first stream is equal to this number multiplied to this flow, and this one is also equal to this number. Okay, and the summation of these two cells must be equal to this one. It is okay. And the second stream must be again molar flow of ethanol in second stream again is equal to this one multiplied to this total flow. Okay, and the summation of these two cells must be again equal to this one. So let's check. Okay, it's now. Make sure that specifically when we are linking Excel and Matlab, make sure that under this section, the checkbox of automatic is okay. Otherwise, it won't calculate the blocks by itself. Okay, the temperature was assigned to 31 degrees Celsius, okay, and the other one was 36. Okay, the pressure is equal to 2, but I'm not going to say that it is equal to 2. I'm going to say it's equal to this cell, and the same for the other one. Okay, so everything is okay, and I'm going to say that this water, make sure that you are specifying the output under this sheet, do not change the other one. Okay, so the molar flow of first stream is equal to this cell This is the summation of these blocks, blah blah blah. It's for the previous template, so you can just delete that. And I'm going to do this one again. Okay, now I have specified the outlet streams. So if I get back here, nothing is changed in Aspen Plus simulation environment, so I can see the run button. First, I have to reset my simulation. Okay, and I'm going to close this one, Okay. So now I'm going to run the simulation again. Now results must be available without any errors or warnings. Check out here. So the same happened. Let's check out the outlet streams here. So we have data. It's not empty anymore. And the temperature, okay, minus, there is a problem here. Okay. Okay. Okay, there is a problem here. Oh, this is initial stream. Okay, now I got that. Let's get back here in Excel. The input data for temperature and pressure has been sent based on Kelvin for temperature and based on Pascal for pressure. And so I'm going to add a unit as a reminder, add a column as a reminder, and writing down the units. It's Kelvin, and the other one is this one, Pascal. Okay, the same scenario is for outlet streams. So to calculate the output of these rows, I must change the unit. Okay, here, and this must be multiplied to changing the pressure to Pascal instead of bar. So I'm going to say again to this one. So I'm going to get back here and reset my simulation again and run the simulation. Let's see what will happen. Okay, everything is fine, no errors, no warnings, and the temperature and pressure for both streams are correct, and the total flow, 60% of total flow is for first stream and 40% is here, so everything is okay, and the data, everything is working correctly. So I can change the input, for example, to 300, and I can also say that I want to the pressure of first stream must be, for example, equal to 2.5, and I want 70% of total flow for first stream. I want to run the simulation again. So the revised parameters have been sent here, 70%, 2.5, and let's check out the outlets here. Okay, that's again 60%, 70% of total stream is here for first stream, and the pressure and temperature. I can't change temperature for both streams because I didn't change anything about these temperatures in this simulation environment. I assume it is the output of my own developed model inside Excel. So at this moment, Excel sent back the data correctly. So these two software are linked accurately. There isn't any problem. In next section, I want to link Excel and Matlab and makes them able to dynamically exchange data. You can find about issues, topics which we are going to talk about in this particular reference. Okay. There is also a template provided by Matlab to link Matlab and Excel and which makes them dynamically exchange data. You can find it here. So take your time, pause the video, and copy the link. Or you can also say Matlab, Matlab open file location. X link, okay, and this is the template provided by Matlab. So what I'm going to do is that at this moment I don't have any icon about Matlab here to link Matlab and Excel. I just come here, add-ins, go manage, okay. So if you don't have this checkbox here, you have to browse the template, which I have already mentioned. So this is my template. I must copy this address, okay, and paste it here. So this is my template. I can press OK, but I already have this one here, so I'm going to press just OK. Make sure the checkbox is everything is OK. I'm going to press OK. So Aspen now is Excel is now trying to open a Matlab file, so it may take some time. Okay, now Matlab is linked with Excel, okay, and there is also a Matlab which is opened. Okay, it may take some time. Okay, now Matlab and Excel are linked, and I want to, at this section, I want to make sure that Excel is able to send data to Matlab, okay? Or it's not okay for now. Okay. There is different ways to send data from Excel to Matlab. You can click here and send name range to Matlab. This is one way, and the other way is to send name range to Matlab. Okay, I'm just clicking this one, and if you see, here is some matrix, some variables which have been sent by Excel to Matlab. If I click one of them, okay, these numbers for Aspen input are exactly equal to these numbers, okay. Apparently, there is a name and there is a Aspen input variable in Excel, and you can find these variables. You can find all of these variables in this section, name manager, and here there are some variables based on your simulation inside Aspen, based on data which you have sent from Aspen to Excel. And there is also a matrix for Aspen output. So I'm going to close this one, check the Aspen output. It is a two-column matrix because I had two output streams. So I can send data to Matlab. Another way, I'm going to clear the data here, okay? Another way to send data from Excel to Matlab is to write down VBA code. So in this case, it is ML, I think ML put rent. Yes, I think it was. So if I press Enter key, again, the data have been sent here, okay? So Aspen, Excel is sending data to Matlab correctly, and I want to make sure that Matlab is also able to send back the output, send back some evaluated matrix, evaluated numbers by which is the result of our own developed simulation. So let's say, For example, we have a matrix which is called x equal to 1, 3, and 9. Okay, so I have a matrix here which is called x. I want to get back x from Matlab. Okay, get data from Matlab, and here is the exactly x. Okay, so I can get back the data from Matlab. Okay, now so Matlab is also sending back the data, and in the next section I want to link all of these three software together. So in this section I want to the user model which I have in Aspen must be able to send input data to Excel, and Excel will operate only as a data transmitter, and our simulation will be defined as a Matlab function inside Matlab, and the calculated output is received by Excel, and Excel will send back this data to Aspen. Okay, but we are going to do this section, I mean linking Matlab and Excel by programming in VBA section of Excel. Okay, so let's get back here. Like I said, we have to call our simulation as a function here in Matlab. So I have already written down some codes to save some time. Okay, code Matlab. Okay, so our function inside Matlab must be something like that. It is just a name. Output ped is just a name. You can put it. You can say whatever you want, and the function name is this one. And there is also two matrix as our inlet of our function inside Matlab. I'm sure you are familiar with defining a function in Matlab. I'm going to save this function exactly inside the same folder which other files are. So let's say this is my folder. I'm putting all the files and saving as. Okay, the name is function ped. Okay, I'm going to save what just happened. Okay, this is the folder. So now I have function here, Matlab function, Matlab info here, the same folder, and I don't forget to change this current folder to exactly the same folder which we have all of other files. Okay, otherwise we will receive some errors. So at the next step, these are the same calculations. These are the same calculations which I have did here. These are programmed exactly here. For example, the split fraction of first string is equal to this variable, which we have received from Excel. If you take a look to these numbers, it's 70% of total molar flow of inlet stream, which is equal to first stream total flow. This is the pressure of first stream, and this is the pressure of second stream. So I just specified these parameters to some variables which I have inside Matlab. The molar flow of I have received a matrix which is the molar flow of water and molar flow of ethanol, and the total molar flow is equal to summation of these parameters. I'm going to send the inlet input to Matlab, and these two cells, these two elements are actually these numbers, which are the molar flow of water and ethanol. So I'm just assigning some parameters to some values. I'm not doing something new. I'm just making the same calculation which we had already in Excel. So I'm going to specify the temperature. This time it is based on Kelvin. So it can be anything. For example, solving differential equations to predict the outlet temperatures. You can put your own simulation here. And other calculations are based or for first stream is for total molar flow or molar flow of water and ethanol, and so on. Okay, now I want to specify, I want to send back only one single matrix to Excel, and I have defined a matrix which has only one columns and 8 rows. Okay, the first element is water flow in first stream. The second is ethanol flow in first stream temperature, first stream pressure, and so on. Okay, and the remaining elements are concerned with second stream. Okay, so I have written down the same calculation which I had already here in Aspen Output. Okay, so now I want to say that, okay, Matlab, close this one. Now I have to get back here and write down some codes in this section. Like I said already, I want to tell the Excel, I want to make it able to send input data to Matlab and receive the output, receive the matrix which I have told you here. Okay, so I have already written the code, so to avoid any mistake or save some time. Okay, oh, before doing anything, make sure that under this section a spreadsheet link is clicked. Okay, press OK and paste the codes. You can find about these lines, these codes in the reference which I have already mentioned. Like I said, moutput range will send the all named range to Matlab. This specific line will send these inputs, okay, to function ped, which I have told you here, and will receive the output ped. And I'm saying that after taking back this matrix, put it exactly in this sheet. Okay, what I'm sending to Matlab, it is Aspen input. Like I said, Aspen input, okay, Aspen input was this particular, okay, was this particular matrix, and I am also sending Aspen real params, which is exactly this matrix. Okay, and okay, I'm going to I have mentioned in this line that take the output ped matrix, which is the output, the result of our simulation inside Matlab, and put it exactly in this sheet and in this cell. Okay, let's check where it might be. Aspen output, and H2 is here. So I assume that I have received my output matrix exactly here. Like I said, it has eight rows. So I assume in this section I have to receive my output. Okay, so I'm going to reset the simulation, okay, and click next to run the simulation. The results are available. Okay,
and I have also received the calculation which I have made here. Okay, so now I have the output. The only thing which I have to do is, if you remember, these four streams were calculation for first streams, these remaining are for second stream. Okay, and this one, this element, like I said, is water flow in Fs. Okay, so I'm going to say, if you remember, these were assigned to these cells. I just want to remove all of them, and I'm going to say the molar flow of water is equal to this one. The molar flow of ethanol is equal to this one. The total flow is the summation of this cell and this one. Okay, the temperature is equal to this number, and the pressure is also this one. The same is happening for second string, and okay, and the total flow is also equal to this cell plus this one. Okay, the temperature is this one, and pressure. Okay, so now I have sent the data to Excel, and Excel transmitted this data to Matlab, and Matlab has calculated the output, and I have received it here and assigned to each cells for each S3. Okay, so nothing is new, everything is okay. I think I must be able to just reset the simulation, change this number to make sure that everything is working correctly. Okay, and for example, I also want to change some specification. For example, I want to make it 0.6, and I want to make it for 1.5 and make it 3.5. Okay, I want to make sure that everything is working correctly. So by pressing only one key inside Aspen, all-tier software must be able to dynamically exchange data. Let's check out the result. Okay, the temperature, okay, the pressure, okay, changed is here to 1.5. Okay, other pressure is 3.5. 60% of total flow is here, and 40% is exactly here. So these three software are exchanging data. If you have any problem inside your programming language in Matlab, you can just click, you can pause your codes here, for example, and you can change something again, for example, 150, and run the simulation. Okay, you can see that here it is calculating, and Matlab is showing me something. If I come here, I can see that the run is paused inside Matlab, and Excel, okay, and Aspen is waiting to receive data. Okay, now I can check my results here. I can check my different parameters here. For example, I can, for example, say I want to do something here. For example, what is this number? Okay, this is, and maybe I want to make check the mole fraction of first string. Okay, to make sure that everything here is working correctly. Then, if I press while, Aspen is still calculating. If I press to continue, okay, the calculation is done, and Aspen is received the output. I can check again the results, okay, and make sure that everything is working correctly. The total flow string was 150, and the 6% is here, the pressure and so on. So we have linked three software together To dynamically exchange data, like I said, the purpose of this procedure, the purpose of this method is that which is making us able to put our own developed model inside, for example, Matlab inside the simulation environment of Aspen Plus, and then integrate that single equipment to other equipments, other sections, for example, reaction sections or separation sections, and then carry out a more optimization on the whole unit, not just a single unit, to investigate the effects of different parameters and variables on the final products. So that's it. I think everything is working correctly.